Before we do, let's just have a very quick look at these source files that were code generated. All code generated. Here's the file IO class. File IO allows you to create an instance of it. This is the constructor. So when you create an instance of this, it will go and physically open on vinyl data, vinyldetails.ism. That's all it does. And if you specify a mode, okay, so there's an alternate constructor where you can specify the mode, it'll open the same file, but it'll open it in whatever mode you specify, i.e. normally update mode. And that's essentially all it does. This check-in range, you can ignore it. The only reason for this check-in range is if you have tag. It is a tag in the repository, isn't it? Field tag. So that's what that is. I'm not going into huge details about the data object. We'll talk about that in a minute. The data field mapper, this is where it simply says, okay, what's the field name? So get the actual name and, no, those are positions, sorry. If it's barcode, then set up some parameters that detail that field. So the name is, the data type is, the element, the structure position, and the decimal precision. Okay? That just tells Symphony Harmony where the physical data is in your record area. When you're doing select barcode from vinyl_details. It now knows where barcode is in the physical data. That's all that's doing. The table mapper says, okay, if you ask for a table called vinyl details, what you actually mean is on vinyl data vinyl details_.ism. Okay? Under the hood, Symphony Harmony is using the select class. The select class has a from. That from opens a data file. That data file has to be a Synergy data file. And you reference Synergy data files using logical file name. But you don't put select star from on vinyl data vinyl_details.ism, because that would be long-winded and boring and not SQL-like. Okay? So you just say vinyl details, and I map that table name to the physical file name. And then the big beastie, the code-generated data object. I'm not going to go into a huge amount of details here, but these are the data converters. So that's how it can convert data from one type to another. Where we've got barcode, A20. So I'm exposing it as a Synergy Alpha 20. Okay? And a bit further down, one thing that is built into here is these structure to byte array and byte array to structure. Let me just find one other thing. That. Okay, this property here, it's attributed, JSON property. One thing Steve was talking about, very validly, when he's doing his REST API and all that kind of stuff, you give it a class, or it returns a class, but it doesn't return a class as a class, it serializes it into JSON. So each property, it'll go property name value, property name value, property name value, property name value. Okay? And Steve demonstrated that and showed using Postman, and you put the REST query in, and it called the REST server, did the method, and that then serialized it out into JSON and brought the JSON back, and it displayed that JSON. Field, property, field value, field value, field value. And that is brilliant and all well and good. And Harmony used to work exactly like that. So if you had a data object with 5 fields in, you would serialize it, and Symphony Harmony would bring it back, and I would get back in the client field value, field value, field value. Fantastic. But then when they started using Harmony, they don't have nicely structured record areas with 5 fields in. They have extremely busy record areas with dozens and hundreds of fields in, lots and lots of fields, with groups and arrays and all that kind of stuff that blow out to individual fields. And they never want to bring one record back, they want to bring hundreds back. So what was happening was the JSON got very big. So for every record that had 100 fields, you get field name value, field name value, field name value. Okay? And what I found was, from a JSON parsing serialization point of view in the Newton stuff, it was, I'm not going to say slow, but it was quite slow in building that big JSON up. And I worked with Jeff and we figured out what would be better, instead of serializing out every single field, if we moved all that data into a byte array and then serialized that? So we basically get serializable synergy record, big byte array value. And we get one of those for each record or each object we bring back. Now that's all hidden away under Symphony Bridge, and then that comes across the wire, and in Symphony Harmony I deserialize into that one, and what happens is when the JSON deserializer runs, I take each of those elements that I know in the byte array and put them into the actual fields, barcode, artist, title, etc. So I still serialize the data object, but I don't serialize every property, I serialize one property. And it's a hell of a lot faster. Okay? If you look at the JSON when it comes back to the client, you just see a stream of bytes because it's a byte array. So it's meaningless to you, but it's a hell of a lot faster. So, yeah, JSON serialization is great, but just be cautious of performance if you've got big data going to and from. So that's the data object. So now what we're going to do is do the desktop. So that's our server. We're now going to create a completely new project. Add, new project. And we'll call it on vinyl maintenance. And it's not going to be a class, it's going to be a WPF application. First thing we're going to do is create some folders. I am going to create a folder called content. I'm also going to create a folder called converters, and I'm going to create a folder called resources, and then I will create a folder called view, and a final folder called view model. The reason I've done this is we're going to code generate a bunch of stuff in a minute. Content, when we code generate something, will have nothing in it. Well, it will, it'll have a file in it, which will have nothing in it. But if I'd have got selection lists associated with fields, that would code generate various elements and put them in the content. And they would then display and show as drop-down lists in our user interface. Unfortunately, we don't have any of those. If you're interested in that sort of stuff, there are lots of tutorials. There's a Symphony combo correctness that talks through how that all works. The converters, we're going to add a piece of code later that allows us to protect against null images, because the XAML image displaying control gets really upset if the image is null. So we're going to protect against that. The view model, that's where we're going to put our view model code, and the view, that's where we're going to put our view code. Okay? And I'm also going to create one called images. What I am going to do is copy and paste. I think I can do this. Open in folder. Let's go into my images folder and just grab this and dump it into there. It's just an OK button that I found on Icons 8, and it looks like that. And that's what our OK button's going to be looking like. So we need to import that into here. Add existing item, images, and it's an OK button. Just check it's got the right property as a resource. Yes, it has. OK. So what we'll now do is we'll add a... Did I add that into there? Oh, I didn't. OK. File, new, and we'll create a text file. And what we're going to do now is we're going to add some code that will run CodeGen. So it's exactly the same sort of thing. If we save that, we can save it as, we'll change that to desktop. All this is going to do then is going to use the same structure vinyl underscore details, and it's going to create Symphony collection. That's what, if you've got selection lists associated with fields, that's what collection and content both handle. And then style is the one we'll look at, which is the prompts and the fields. So if we drop down to our, do regen again, desktop, file generated, file generated, file generated, okay? So let's just add those into the project and we'll see what they do. So if we look in content, it's created this vinyl details collection. So let's have a quick look at that. I told you there'd be nothing in it, and there's not. There's a placeholder, just so the stuff will compile. But if we had selection lists associated with fields, they would appear in there. The next one is our resources folder. So if we add existing items into there, and go to our resources folder, we've got two. We've got content and style. The content is basically, there's nothing in there. Again, if there was selection lists associated with fields, we'll get pointers to those selection lists in that file. And then the final one, and we'll get lots of blue squigglies in this potentially, don't worry about the blue squigglies, is basically I'm creating a style called vinyl details barcode prompt. The name is the structure, the field underscore prompt. And any information associated with that field, such as the prompt, is included there. And notice this little bit as well, this is enabled. If you use a label control, then when you disable the field which is associated with that label control, the label will take a disabled appearance as well. So you get a double indication of something that's enabled or disabled. Again, ignore the blue squigglies for the moment. This is our input style. And this is where there's lots and lots of logic that help you define the user interface. The things you need to worry about are here. The text is what you physically see on the screen and what you can enter into. So we're binding that to our barcode field. Remember the barcode field in our data object? That's what we're data binding to. That data is an alpha 20, so we need to use an alpha converter. That alpha converter is delivered via Symphony Conductor. Validation means that if that field is flagged on the data object as not being valid, we need to display that, we need to indicate that, and we'll see that as we run the program. Maximum length is the number of characters they can type into it. That's been restricted to 20 because it's an alpha 20. No point in allowing them to enter 50 if you can only store 20. The width is just a best guess of how wide it should be, and that's just something that CodeGen's doing for us. The tooltip here is basically, if that field is in error and you hover over it, the reason that field is in error will be displayed in the tooltip. This logic here allows that field to grab focus. Remember, if they say, excuse me, I want focus, it's up to the user interface to do something and honour that request. So that code honours that request. And this little bit down here, it changes the way we display things. If that field is in error, we'll get a reddish background if the field's in error. Now, none of this is going to build straight off, and the reason it's not going to build is very simple, and there's more to add. But the first thing I will do to start getting rid of those blue squigglies is I need to go into NuGet and go into Symphony and say, I need the Symphony framework, please. And then again, it comes up with the Richard is ace dialog, so you say, I accept. That'll tidy up all those blue squigglies. There's another thing I want to add to the resources folder. So let me just bring up here. One thing we have, there's something called app styling. Now, if we didn't use this, it would look like sort of normal white windows and all that kind of stuff. But if we add this in, and we'll add it in here, and just check they've all got the right properties. Not page, see, they don't want to be page, they want to be resource. Okay. If we look at app styling, what we're doing in here is basically defining standard styles, standard colours. So these are just standard colours, control mouse over colour, a blue colour wants to be that. And then further down we can say, okay, if you're a window, then your background property. So every single window I now create will have a background property of these grey colour, black colour. Okay? Menu buttons will have this is a template for a menu button. This is what the menu button will look like. If we look at things like the label will have a font size of 12. Once we get this working, we'll change that and see what happens. Okay? Same for a text box. It's got a font size of 12. We'll change that and see what happens. So that's the XAML. That's how it's going to sort of look. Now, I'm not going to write lots and lots of code today because obviously there's stuff we need to be moving on to. So in the view, I'm just going to copy these files across and then bring them in. And we'll have a quick look at them once they are in, just to make sure they're all hunky-dory, as they say. They're all Bob's your uncle. Okay, that didn't bring them in at all, right, did it? That could give us a problem in a minute, but we'll see. We'll see how we go. That's the full input one. Yeah. It's not brought them in properly, and I don't know why. Okay. These things come to try us. As I said, we're going by the seat of our pants today. And it's all good stuff. Let's delete those. Let's remove them. Let's bring them in one at a time, see if that helps. Existing items. So if we bring in error dialog, add. No, still not doing it. Well, let's have a look at. Null converter, that's fine. Okay, I can fix that. Let's bring the null converter over. I told you I was creating a converter. Let's bring that over. Now, you see, my original plan was to just bring the whole project over and say, there you go. But doing it this way, you're actually going to see how things work. But we're getting there. Converters. That null converter, as I said, it protects for null images. So if we get a null image, we go on to display a not found image instead of having a null image displayed, because you can't display a null image. Things are not coming in as I would have expected, Jeff.
What's sort of coming in?
I'll show you. So if I bring all those in, you see what I mean? That should hang off that. It's all building though. That's fine. Don't worry about those. We've not added the view model yet. So it's just the representation in the Explorer. We might be able to look at these. Oh, we can. Right. Just as a sort of FYI here, the reason I was sort of, it appears to be just the way that these are being displayed in the Solution Explorer, because the full input.xaml is great, but the full input.xaml.dbl should hang underneath it, because it's sort of a partial class, it's a child of it, okay? So it's just the way it's being displayed, but we can see the results in the XAML editor here. So that's what it's going to look like, and on here we can see where we're using the label and the field controls. So there's our barcode prompt and our barcode style. So those two lines of code are the same as your .input in a toolkit window. It's exactly the same. Oh no, okay, they're different, they look different. One's in XAML, one's in Synergy UI toolkit script. But conceptually they're exactly the same. Because we've created those styles, we can now do the toolkit equivalent of a .input. And that's the label and the actual field control. And as you can see, that's the results at the top of the screen up here. Barcode, field entry. Okay? So what we now need to do is bring in the view model, because we've sort of got the view and we've got the model, but we haven't got the view model. So I'm going to bring a couple of files over now into view model, and then we shall talk about them, see if they build, and see what happens. In my view model folder, add existing item. First one we'll look at, we're not going to look in great detail at this, is the file maintenance view model. This one comes from the Symphony framework community. directly. I brought it in here. In theory, I could reference it from a library over there, but I'm not going to. I've just brought it in. It extends this base view model class, which that's built into the Symphony framework. And inside that, there's various things about making visual states and all that kind of stuff. Not going into huge amounts of detail. But there's a lot of logic in here. So, the framework element we get passed in, that's the view, that's the master view. The data item, it's asking for an at type, so we're going to pass a type of data object. And we pass a type so it can create a dynamic instance of it using reflection. File access, we're going to pass in a file IO class. And error visual state is a string. That's the name of a visual state to navigate to if there is an error. That is a really good way of saying, do you want to navigate to are you sure you want to delete visual state? Then the user interface can define how he wants the question to be asked. Now it could be that the user interface says, you know what, I'm not bothered about asking a question. If they hit delete, they want to delete, boom. But it gives the user designer the option to say, I will put up a nice pink window with a big red blob on the side and a man going, don't do this, in a little animated GIF when you hit the delete. And then you can hit the yes, I do want to delete, or no, I don't want to delete. That's the idea. And this class creates data objects, it creates collections, it loads all the collections, and it loads all the data ready for you to be able to display. And it does all this using lots and lots and lots of code that we've got working. So we can actually forget about that and just look at our vinyl maintenance. And the reason I want to go into this is what you actually have to code for your program. It says extends file maintenance view model. Now from an OO perspective, that means, do you know what? There's a whole bunch of cool logic inside file main view model that I want to be able to use. So I'll call mine vinyl main view model, but if I extend the file main view model, that means vinyl main view model has everything that file main view model has, plus all the stuff that I'm going to code into this particular one. So that's the way in OO that you extend and add functionality to base classes. We'd call file main view model a base class, and we're extending its functionality to make it specific to my program. So that's an OO technique for those of you that potentially are a bit new to OO. The constructor then, and you know a constructor because there's no return value and it's the same name as the class. So whenever you create a new instance of the class, the constructor has to get called. It will always get called. You cannot create a class and the constructor not get called. You can then inject, as they say, data that's been injected into you. This is dependency injection. This class is dependent on you giving me a framework element. You cannot create an instance of this class without giving me a framework element. Whether that framework element is the right thing or not, is it, does the right thing, I don't know. But you cannot create me. I am dependent. If I am a final main view model, I am a class that is dependent on a framework element. So you have to inject it to me. This is what we call dependency injection. And you do that by defining it on the constructor. So when you create the object, you have to give me some sort of framework element. I can then pass that on. This parent says, because I'm extending something, I want to call into that something's constructor. So I can call my parent. So file main view model is the parent of vinyl main view model, and I'm calling into it. I'm passing through the same sender that was passed into or injected into me, and then I'm adding additional things on here. So I'm saying type of vinyl details data, that's my data object, and then a new instance of my file details file IO. So now it knows what sort of data I'm doing and how to physically get at that data through the file IO object. And then I've got this show error state, which is the name of visual state that it'll move to if it gets a key not same or duplicate error type of thing, some sort of file IO error. And that's pretty much it. One thing we do, this program mode changed, the parent file main view model has an event in there that says, Okay, the mode, the operating mode of this program has changed. I am no longer in you can select things from the list. They've gone into add mode, or they've gone into change mode, or what have you. Okay, your program may need to know it, so we raise an event. You don't have to listen to it, but if you do, you can do specific programming for your particular program. So in here, I've got my event handler. It's an event handler because it handles this event. It's a named method that handles or is executed when this event raises. And I get passed what mode I'm in. There's no common variables anymore. I get passed. I get injected the state of me, this program. What mode am I in? Well, if I'm in modify mode, and it's an enumeration, okay, if we look at that, it should show us. It's an enumeration. So we've got program mode. Am I in key entry? Am I in modify, add, inquire, remove, drill, lookup? Okay? If I'm in modify, then I want to set read-only status on the data object of the field barcode to true. I want it read-only. Remember, I enable and I disable? That's the equivalent to I enable and I disable. Although I'm making it read-only as opposed to disabled. So they can see it, they can touch it, they can't change it. Because I'm in modify mode, I don't want them to be able to change the primary key. And then, remember in Toolkit you've got iNext. That's the equivalent of iNext. Artist is focused, take me straight to the artist. When they go into amend mode, put the artist as focused. If I go into add mode, so I've clicked the new button, as we'll see momentarily, then I want to set the read-only status of barcode to false. Because you wouldn't be able to create a record if you couldn't enter something into the primary key. So that's now writable. And then underneath it, like I do in iNext, the equivalent of barcode is focused. Please, user interface, will you put focus in this field? That's what we're asking through the view model. Doesn't necessarily mean you're going to do it, but we've asked. We've done our best. And that's literally all the coding there is in the view model that you code for this program. Okay, does it build? Can't find my own vinyl data. I've forgotten something, haven't I? What have I forgotten? I have got a project here called on vinyl data. Just because it's in the solution doesn't mean all the other projects know about it. So I've got to tell it that I need to reference that project. So you can reference the physical file on disk, you can do something with COM, it might be a .NET assembly, but in this instance it's a project. It's part of my solution. So I'll say, yeah, on vinyl data, that's my project, that contains my data object. Now does it build? Build succeeded, okay? So it's built. Before we can run it, I need to set it as the startup project, okay? Before I run it, what I'm going to have to do is say, set up some logicals. Syn, CK, I, and I. So in here, in my Syn user, I'm going to say on vinyl data. Remember the logical that was defined in the repository that was then included in the code generated file IO equals C:\/ on vinyl data. Okay? Happy? Ecstatic. And then what I will do, I will bring up my Explorer. I'll go to C:, and I will then go to my, and I will dump that on there, and it should create on vinyl data. And I've got my data file. Now there's some records in here. We weren't going to start off with a completely blank thing. One more other thing. Those are all the views. The main program, we need to add some stuff into here, because this knows nothing about what I'm doing. This is just, well, if I run this, even though I've got all those fancy views and all that kind of stuff, nothing's going to happen. It's going to run, but I'm going to get a main window of nothingness, because I've not added, I've not pulled everything together. So what I can do is, I'll type it in, what the heck, life's for living. So XML namespace : UI equals, and in theory, if I start typing on vinyl and find the view, so all I'm doing here is finding the namespace on vinylmaintenance.view that contains my user interface components, those windows that I created and we just had a quick look at. Okay, let's change the title, so on vinyl, on vinyl maintenance. Let's change the height to, I don't know, 600 and the width to 800. Give us a bit more space. And then in here, everything's inside some sort of container, so it's in a grid. I can do UI, colon, and those are the 4 views that I've created. I know we only looked at a couple of them, but I'm going to pick the maintenance one. The maintenance one pulls together the overview list and the full input. Okay, so I'll do that. It says I can continue working. Let's not worry about that for the moment. Let's just see if it runs. Because the XAML designer can have a bit of a hiccup sometimes. Okay. The calling thread cannot access this object because a different thread owns it. Something's not thread safe. That's not good, is it? Okay. Maybe we need to add a little bit of logic in something that's hidden away in the background. And that will be that if we look in this app.xaml and look in the app.xaml.dbl, we have a class called app. And this is the first thing that runs. This is our app-based application class. I'm going to create a constructor in here. And in there, I'm going to do symphony.conductor.static.threadsafe.anchor to UI. What that line of code does is say, Symphony Framework, this is my main UI thread. Because I can't determine, the Symphony Framework, nothing can determine what UI thread is. There's no way of saying to a thread, hello thread, are you a UI thread? Okay? You can't do it. So you need to be able to control it yourself. So I'll do that, and hopefully things will work a little bit better. So now I'm moving up and down, and I'm seeing, I really don't know how I'm seeing those images. That's quite clever, really. Oh, it's because it's the full URL, isn't it? The image URL is a string that holds the whole image URL. That image URL is coming from the web. They're not held locally in the program. They're coming from the web. Okay? We'll look at that in a minute. So you've got a maintenance program. Happy?